Okay, this recording is to explain dilution factor calculations and what is the meaning of dilution factor, and also calculations involving the equation C1V1 equals C2V2 and what that means. So we'll start with dilution factor. Dilution factor is sometimes given as a number. I'm just going to put a blank for right now. And then a colon, not a line, a colon, so dot, dot, and then another number. So maybe it's a 1 to 10 dilution. That would be a fairly common dilution factor. What that means is you're going to start with one part of your concentrated stock solution. So you always have a concentrated stock solution that you're diluting. And you're not going to dilute all of it. You're going to pour out a certain amount of that concentrated stock solution, measure it out, one part, could be 1 liter, 1 milliliter. And what you're trying to do is to make 10 parts of your diluted solution. So if you start with one part concentrated stock solution and you're supposed to make a 1 to 10 dilution, then what that means is you need to end with 10 parts of diluted solution. Now, what do I mean by parts? Parts can be any unit. So if you start with 1 milliliter of stock solution and you're supposed to make a 1 to 10 dilution, you're supposed to end with 10 milliliters of the diluted solution. That's what that means. Now, how much water would you need to add to the concentrated stock solution? If you had 1 ml of concentrated stock solution, how much water would you need to add to end with 10 ml of the dilution? Well, you need to add 9 ml of water. But the amount of water is not indicated here. You just need to think about how much water would you need to add to 1 ml of stock solution to end with 10 ml of diluted solution. So it's 10 minus 1. So it'd be 9 ml of pure water. Sometimes when we're looking at the dilution factor, sometimes it's written as the diluted solution amount here divided by the concentrated. So the final volume, V final, over V is volume, over the volume of the initial or concentrated stock solution. So in this case, if we gave it in that format, then your dilution factor would just be stated as 10. But in our beginners class, we usually use this format over here. 1 to 10 is our dilution factor. So the volume on the left side of the colon is the volume of the initial solution. The concentrated stock is always what you're starting with. Sometimes we call that V1, the initial solution. Or over here I showed it as VI, the initial volume of the initial solution. And the diluted solution, the V final, sometimes is considered V2, the second solution, the diluted solution. So V1 and V2. That's another way of showing it. But in any case, whatever's in this blank is the volume of the concentrated stock, and whatever's in this blank is the volume of your final diluted solution. So if you start with 1 ml and you add 9 ml of water and then that makes 10 ml, then that's called a 1 to 10 dilution factor. All right. Now, this is related then to another kind of question which involves an equation. And it actually ends up being a very fundamental equation for working in the laboratory. Hang on, let me see if I can just erase all of it. Nope. Let me do this. Delete. There we go. All right, so this ends up, what I'm about to write up here is a very basic equation for working in the laboratory and figuring out dilutions. C1 times V1 equals C2 times V2. So this equation is true. It is correct. It is something you don't have to figure out. It's just set. So if you're given a dilution factor as part of a word problem, then what they're giving you is a number for V1 and a number for V2. Like in my previous example, 1 mil of the concentrated solution and 10 mils of the final solution. And sometimes they'll also give you either the concentration of the stock solution or the concentration of the final solution. So let's say they give you the concentration of the stock solution. Let's say you have 10% stock solution of some solute. Then they're going to ask you, they have to tell you 3 out of these 4 variables, and they're going to ask you to solve for the other variable. So let's say they give you a problem where they say you make a 1 to 10 dilution starting with a 10% concentration stock solution. What's the concentration of the diluted starch solution? So they're telling you the concentration of the stock solution, 10%. They're telling you it's a 1 to 10 dilution, which is their way of telling you V1 and V2, and they're asking you to solve for C2, the final concentration of starch in this solution. One thing to keep in mind is whatever units they're using for C1, that will be then the same units for C2. So they're giving you 10%, so your answer will also be in percent. The volume of the stock solution has to be in the same units as the volume of the diluted solution, so that has to be consistent. So then it just becomes an algebra problem. 10 times 1 equals what times 10? Sometimes I fill in C2 here as the variable, the unknown variable. Well, 10 times 1 is 10, and then you get 10 times C2. So in algebra, you would divide both sides by that coefficient, and you would get C2 equals 1. So you would have made a 1% starch solution as your diluted solution. So that is the definition of dilution factor, and then an explanation of C1V1 equals C2V2 as how you would solve that in a word problem, or frankly in a real laboratory situation to make a dilution. So they have to give you 3 out of the 4 parts of this in order for you to be able to solve the last part. So I hope this helps.